and then we'll get going. Hello and welcome to a special episode of Off Chain. I have with me a very special guest, Fluffy Pony. Hey, Fluffy, how's everything going?
Good, thanks.
So you're in South Africa at the moment, is that right?
I am. So we have the pleasure of recording this on South African internet, which means there might be a ridiculous lag between me saying something and you reacting, but we'll just have to deal with it and roll with it.
Yeah, I guess so. I mean, to some degree, I'm hoping that I can edit this properly. I don't know much about video editing, so if it comes out crappy, it's not my fault. Well, it is my fault, but yeah. It's just,
well, look at it this way. I mean, at one point you didn't know much about blockchains, and now you're like, a blockchain expert.
Yeah, we all have to start somewhere, right? Yeah, we all have to start somewhere.
Maybe in like a year's time, you'll quit blockchain and become a video editor full time.
Yeah, either that or crypto kitties. I'm really excited about crypto kitties.
Yeah, if only the Ethereum network could handle it. That would be ideal.
Well, I was thinking crypto ponies. I think that would be awesome. Like breed little ponies or something like that. I think the Riccardo pony
I don't know
would
if
be
the
the most
Monero
expensive.
network. Yeah, of course. I don't know if the Monero network can handle that scale, though. I mean, let's be real.
I mean, that is true. That's going to be quite the scale we need for that. But yeah, how's everything going with Monero and all? I mean, like there's just so many interesting technical things that have happened in the last month. I can't imagine. I mean, like between MimbleWimble and Bulletproofs and things like that, the technical landscape just looks really ripe for Monero to do something really cool.
Yeah, it's what I like about it is Monero's community and the developer work group are largely they're more interested in technical advancements than anything else, which may honestly may be a weakness in some people's eyes, but I'd rather we focus our efforts on making Monero a much better product than focusing all our efforts on marketing type things. And that's not to say that we aren't doing something in those lines, but the focus has always been, and I think will be for the foreseeable future, on making a really good product, and on building something that's useful for us, because that's one thing that I really appreciate is that everyone in the Monero community and all the developers that work on Monero, and there's over 300 of them that have worked on Monero, everyone eats their own dog food. Everyone uses Monero. Stuff that comes out in issues and all that, it's not relying on bug bounties. It's people in the development work group that are like, oh, I was trying to do something and this broke.
Yeah. I mean, I'm certainly watching it very closely. So, just to give everyone an idea, I know you guys have been talking a little bit, at least, about bulletproofs as a way to reduce the range proof size. Do you want to sort of explain that to our audience a little bit and maybe talk about Monero's plans around that?
Sure. So Monero's range proofs are pretty big, and where we use range proofs is we have an implementation or not an implementation, but we have a technology based on confidential transactions that Greg Maxwell created. And we call it Ring CT because it basically bolts confidential transactions on top of Monero's ring signatures. And one of the issues with confidential transactions, not issues, but one of the potential issues is that because you're using commitments, you could have a scenario where somebody could use negative numbers and create money out of thin air. And so the way we get around that is we use range proofs to prove that the numbers are positive. And so then you can subtract the one from the other, and the outputs cancel the inputs, and so you know that a transaction isn't creating new money. The problem is that range proofs are big. So a typical Monero transaction is like 12 to 15 kilobytes, which is huge for a
single transaction. Yeah,
stored permanently on the blockchain on thousands of computers. So Bulletproofs is this new creation or new cryptographic scheme, a new way of doing range proofs that significantly reduces the size. And again, Greg Maxwell is involved, although he's not one of the lead authors in the paper. But it's nice because obviously Greg's involvement means that he approached that and worked with the authors to make sure that it's something that works with confidential transactions, that it's a compatible range proof. So this paper was published a little while ago, and the Monero Research Lab sort of jumped at it because the longer you leave big transactions on the network, or the longer they occur, the uglier it becomes. You can throw away range proofs in a prune node, but for archival nodes, you have to store that forever. And obviously, we want to make sure that the impact is sort of minimized for future generations. So they've been playing around with it. They have a Java implementation of bulletproofs on a single output. Now, bulletproofs don't scale linearly when you have multiple outputs. There's a whole clever little trick there that makes the scale like fantastic for multiple outputs.
I think it's logarithmic,
so
right?
The space saving is not just like, cool, a transaction with two outputs, which is the standard. You can now create a transaction with, let's say you're a mining pool and you're paying 50 miners at the same time. The cost saving will be massively broad, just be huge. Now, we haven't gotten to the multiple output implementation, but we have done the one output implementation, both a research sort of toy implementation in Java as a proving ground, and then that's been ported over to C++ already. And this is really fast work because the Bulletproofs white paper was so well written. And so the next step is this weekend, which is the week of the 4th of December, the Monero testnet is going to fork, hard fork, these new range proofs in. And it'll basically be one bulletproof per output. We're not doing the multiple outputs thing just yet. And then we'll see how it goes on testnet over the next few months. And if it goes well on testnet, and if there aren't massive hiccups and explosions, then we're hoping to include the single output bulletproofs in the March hard fork that happens next year.
Oh, wow.
So yeah, it's super fast work. It means that we have about 4.5 months of testing, which should hopefully be enough time to, for any nibblies to crop up. But the crypto is not complicated. The math is sound. There have been a lot of eyes on this paper, and we're hoping in the next couple of months there'll be a lot of eyes on our implementation of it. And this should lead to like an 84% reduction in Monero transaction sizes from March next year, if all goes well.
And how big is the Monero blockchain right now? Like how much savings can we sort of expect going forward?
Well, let's see. Please hold whilst I check the Monero blockchain size. Okay, so the blockchain on disk is about 34 gigs. That's obviously using. That's got a bunch of indices, whatever that thing. Because we denormalize a lot of the blockchain data and duplicate it really in indices, because we need to for performance, and so that's pretty chunky. But the raw blockchain is 26 gigs. So it's not insane, but it's still pretty big. Obviously, there's a large chunk of that is range proofs and signatures, and in a prune node you can discard range proofs and signatures. But like I was saying earlier, archival nodes need to store them forever. So it's not really worth looking at it and saying like, if treating a prune node as an actual node, because it's not really. With all of this stuff, you want to sort of view it as like, what's the impact on an archival node, because you want to maximize the archival nodes in the network. So yeah, like we sort of expect to see quite a significant cost saving or space saving going forward. It won't reduce the current blockchain on disk, but sort of future transactions from that point on would be reduced.
Is there any way to sort of like take a snapshot of the current UTXO set and start a new chain with something like that? Would that be a hard fork you would ever consider?
So, yes, it is possible. The problem is that base UTXO set, sharing it becomes like complicated. So you can do things like have a hard-coded hash of it, and that's the Genesis, the new Genesis block. And then you go, cool, from this point, this is the UTXO set from when we had ring CT or whatever. And we can discard everything else before that from a mixable UTXO perspective, because we don't create ring signatures with them really. And then if you do need to create a transact, like if you've got an old wallet that's got that's cold storage from before ring CT, you'd have to obviously have the full blockchain in order to go from non-ring CT to ring CT, which is a special type of transaction.
Right.
But we could create a new Genesis block. The problem is that UTXO set would always need to be kept, because new nodes syncing up on the network would have to request the UTXO set because they have the hash of it, and then take that UTXO set, compare that they now receive from a node, compare it, make sure that the hash matches, and then sync up from there, sync up normally. It is feasible. It's kind of an ugly mechanism, and it does. Unfortunately, you can never throw away the full blockchain before that in its entirety. You'd have to sort of have a snapshot of the entire TXO set, and then the snapshot of the newer TXO set for fast and for prune nodes. Yeah, it's feasible. It's just chunky. And it's definitely something we possibly want to consider at some future point, where we're like, cool, this is definitely something that we see is advantageous.
Yeah. I mean, another way to sort of like reduce a lot of the block size or the 32 gigs or whatever that I've been reading about is MimbleWimble, and obviously they have that whole Grin implementation. Are there plans for Monero to sort of go in that direction, to use cut-throughs to maybe reduce the blockchain size?
Yeah, so we can't use cut-throughs in with ring signatures. They're not compatible, and which for obvious reasons. And I think given the fact that we only want to improve the untraceability, we would probably we'd move even further away from any potential cut-through style mechanism on Monero main chain. But what we can do is we can do MimbleWimble or a MimbleWimble-like system on a sidechain.
How would a sidechain on Monero work? You'd have a two-way peg?
Yeah. So there's lots of clever ways that we can get around that. For example, Lightning Network. Lightning Network's a great example of how to perform atomic swaps without needing to have actual pegs between a sidechain and a main chain. Obviously, it relies on both the sidechain and the main chain being on Lightning Network. But then you could have instantaneous atomic swaps between the two.
Okay. Interesting. So how would you enforce the peg with a Lightning style, or would you not enforce the peg?
No, I don't think we'd enforce the peg. I think we'd just allow atomic swaps between the two. So my thinking was we bounced around a bunch of ideas, and there are a couple of things that we could do that could be really cool. Like we could have if we thought of a nice clean way to do pegs, to do pegs between the chains in a non-federated way. Then what we could do is you could almost have it that a full node would run both the MimbleWimble the chain or MimbleWimble style chain and the main chain. and then a person running it on their phone would only have the Mimble, or on a lightweight device would only have the Wimble chain and perhaps block headers from the main chain. And then you'd have two different address styles, and then you'd make a payment to whatever address the person provided. And obviously internally it would go, oh, cool, I'm paying from main chain to the side chain, so it's a peg. Or I'm paying from side chain to side chain, so it isn't. Or I'm paying main chain to main chain, so it isn't. And that would be one way of doing it. Of course, the trick is, how do you do pegs with, in a non-federated way? And that is currently an open-ended question. There's some ideas that, like Paul Stortz has, to do it with drive chains and so on. But I mean, within the context of Monero, it's a very open-ended question. Okay. So I think what we'll probably end up with, because it's significantly faster to get there, because then there are fewer open-ended questions, is to just have a like a merge-mine sidechain or something like that, that has Lightning, plugs into Lightning, and then obviously main chain plugs into Lightning, and then you can just go from one to the other a lot, using atomic swaps a lot faster.
Oh, so can you do Lightning on Monero? Is that on the roadmap?
Well, there is no roadmap, but if there were a roadmap, there's everyone has ideas for like all the cool stuff that we could do in Monero, and I think that some of those ideas have even been put down on the getmonero.org website as a roadmap of sorts. But Lightning has been on the roadmap for a significant period of time. And we've had discussions with developers, the Lightning Labs developers, and so on, and we're sort of pushing ahead on that as much as we can. Monero, there's not much that Monero needs to do to support it, but one of the big things is Monero needs to have multisig, which is something that is only going in now. So that brings us a step closer to Lightning.
Yeah, so I mean, does Monero, when's multisig for Monero coming out, and how's that actually going to work with ring signatures? That's kind of, from a technical perspective, seems like a very interesting question. So
yeah, I mean, I guess the answer to when multisig is the same as when Lambo. No, the multisig pull request has been sitting in review for a while. Most pull requests don't spend a long time in review because they're small. And so, within a week or 10 days, you have like 4 or 5 people that have reviewed the pull request, and you can merge it. Multisig's a bit of a beast. So it's been in review for some time, and it's undergone a ton of changes since going into review. The theory's been around for significantly longer. I think the theory's been around now for probably about a year and a half, maybe longer, 2 years. Basically what you end up with, and there'll be, I mean, we have the Monero Research Lab have a paper and so on that explains the scheme that we'll push out at some point soon. But effectively, you end up with a multisig that is indistinguishable from a ring signature.
Oh.
Yeah, and we kind of cheat a little bit. It's just I'm loath to say it's hacky because it's not really hacky. But it's just a clever way of doing multisig with ring signatures. I guess in some sense it's closer to like Shamir's secret sharing scheme than like a Bitcoin style multisig.
Okay, so maybe a little bit more like threshold signature, something like that.
Yeah, something like that.
Okay.
And it's, I mean, like it's the obviously like a change like multisig is not just a matter of going like poof, we've added multisig support. There's a whole bunch of impacts, like the RPC calls in the Monero Wallet RPC system need to be updated to allow for multisig, or new ones need to be added. There's new commands for the CLI to allow for multisig transactions. There's a massive change to the GUI that needs to be added. And then you do that, you do all of those, and then you've got subsystems like the mobile wallets, like Monero and MyMonero and all of that, and the MyMonero web wallets. All of those systems then also need to be updated to support multisig. So I would imagine that, well, thankfully we don't need a hard fork for multisig. So it'll, you know, like as soon as it's live and pulled in and people can start using it and potentially lose their money, hopefully not. But in order to, yeah, let's really hope not. This isn't parody, so we're a little bit more confident in our multi-sig implementation. It's a little more sane. It doesn't have a contract that anyone can take ownership of. At the same time, yeah, you know, I mean, when something like this goes out of testing and into production, whilst it's had a significant amount of work put in, obviously, you know, people should use it cautiously at the beginning.
Yeah. So how do you generate like a multi-sig address? You said it's sort of indistinguishable. So I would probably have one address. You would have another address. Is there some operation you do to make that like a 1 of 2 or 2 of 2 multi-sig?
Yeah. So there's trying to think of explaining this on Skype without a whiteboard. Is challenging. But yeah, like effectively what you've got is you've got people that have, or like if you've got 3 parties, for example, then each of them has 2 private keys, and then you're able to always create, like with any 2 of those parties, you're able to combine all 3 private keys together and get the actual private key. So if you had 3 parties, let's say Alice, Bob, and Carol, then Alice would have her key and Carol's key, and Bob would have his key and, let's say, Alice's key, and so on. And Carol would have her key and Bob's key. And so then all you need 1 extra party beside yourself in order to have all 3 keys. It's
effectively a 2 of 3, but it's using something like Shamir, so you need 3 pieces in order to reconstruct the key, something like that.
Correct. Yeah. So you only need 2 key holders, but you're getting 3 pieces. So yeah, it's, you know, and you're able, and this model is able to be extrapolated out to like pretty much M of N. So yeah, it
actually looks more flexible than M of N, because you could have 2 pieces on one person, 2 pieces on another, and one on the last one, sort of like Oracle or something like that, or tiebreaker person. Yeah. Yeah,
you could do things like RoboSigner. You know, everyone's got 2 keys, and the RoboSigner has to be involved. So you know, 2 parties can't collude without the RoboSigner's involvement. So yeah, there's a lot of flexibility and a lot of playing around that you can do with the scheme. So, and the nice thing again is because it's indistinguishable from a ring signature, people can't go like, yes, this multi-sig had 5 people involved. You know.
That's interesting. That's really cool, man. That's like a whole. I don't think I've heard of anybody trying something like that where multi-sig is completely indistinguishable from normal. That's not a feature I've heard from anybody actually.
Yeah, so it's an interesting approach.
Yeah, I mean the closest thing I think is maybe threshold signatures, but nobody's really implemented that as far as I know.
Yeah, not yet.
Yeah,
but soon. Yeah. Soon, TM.
Yeah, the interactivity of the threshold signature kind of makes it a little bit annoying. Is Monero's multi-sig also interactive? Like, do you need to send pieces back and forth in order to sign it?
Yeah, I mean, you know, in every single multi-sig model, there is some interactivity required. I mean, you know, we try and reduce it and make it as simple as possible, and have the path of least resistance. And I think in future we'll get cleverer, because what we can do is once we have Covery, for example, live on the network, then we'll make sure that, like, if you're running a wallet, your wallet will have an I2P address. And because it's got an I2P address that punches through firewalls, that is a directly addressable live thing on the network.
Right, and so you have direct peer-to-peer communication with I2P then. Wow.
Yeah, absolutely. So that will save a lot of hassle, because then everything could be a lot more seamless. You know, it's like, cool, you scan this QR code and it's got the person's I2P address, and now the two wallets are linked, and they're able to do multi-sig transactions interactively without needing to like email chunks of data or read stuff over the phone.
Right, right. And whenever your wallet is online, it's the same I2P address no matter what?
Yes, so you can, I mean, an I2P address is effectively just a public key. So, you know, you can have the same I2P address like from a private key for as long as you want. You can have it short-lived or long-lived.
But for the interactivity, you're going to need to be online in order to sign chunks or whatever. And how many rounds does it, like, I know threshold signatures, one of the weaknesses is you need like 3 rounds before you can have everybody sign it. How many rounds does it, like with a Bitcoin multisig, you only need 1 round, right? Everyone just needs to look at the data once, and then you can sign it. With threshold signatures, I think it's something like 3 rounds, which is kind of a lot. With Monero, how many rounds is it going to be? How many times does each person need to look at the transaction and do something to it?
So it'll just be 1.
Okay.
You know, I'll sort of like do my part, send it to you, you'll countersign or whatever, and then off it goes.
Oh wow. Okay. Oh, that's very little amount of interaction then. That's amazing. Okay. Well, that's pretty cool, Fluffy. That's yeah. I didn't even know about this going into this call, but that's if it's indistinguishable and it's multisig, that brings out a whole you know, the fact that it's got the privacy properties that it has, that makes it really interesting. Okay. Wow, cool. Anything else on the roadmap that I should know about? Like, I feel like you're like telling me all this stuff that I didn't even know Monero hadn't planned.
Yeah, I mean, like, I guess like with a lot of this stuff, it's we're just sort of pecking away at things, and we just keep working at things. A lot of stuff comes out of sort of, you know, the discussions that we have about weaknesses in Monero. So I don't know, like subaddresses, for example. Subaddresses are in master. They're not in the current release, but you know, you can pull master down and compile it yourself. Do you know what subaddresses do?
No, I don't. I haven't even heard of them until just now.
Okay, just now. All right. Yeah, I can tell you something else. So one of the problems with Monero, because it's untraceable and you've got all of this privacy stuff, the issue that you have is that people can reuse addresses, because an address doesn't give you any information that you can see like on a blockchain. So if you, for example, use Shapeshift a whole lot to convert from whatever cryptocurrency into Monero, you'll just use your Monero address over and over and over, because who cares? No one can look at the blockchain and be like, oh, you received, you know, 10 Monero from Shapeshift. The problem is Shapeshift can tell that you received, that you're the same person receiving transactions each time, because you have to give them your address. So you can do, I mean, you could like do it the chunky way, and you could be like, okay, well, what I'm going to do is I'm going to go and set up a new wallet temporarily, and I'm going to use that for a Shapeshift transaction, and then I'm going to scrap the wallet and set up another one. Obviously, the downside there is, firstly, you're paying additional fees to move from the temporary wallet to the primary wallet. Secondly, it's just painful. You know, I mean, come on, who wants to do that? Yeah. So a little while ago, one of the Monero Research Lab people came up with this idea to do subaddresses. And a subaddress is basically like a short-lived or long-lived address that you can create within your wallet that gets scanned along with your normal address. But because it's a single use, or multi-use if you really needed to, but potentially just single use, it's really low impact. And it means that you can, every single time you use Shapeshift, you can just be like, here's the address, and they send the funds to that. And the next time you just give them a different address, and off you go. And so that's, I think that's kind of powerful because it again just reduces an element of traceability that would exist outside of Monero. I mean, we can't control the information that people give to others. But what we can do is give them a system that allows them to reduce the information that they give to others.
Yeah, so this sounds kind of like BIP32 wallets, kind of like you can make a ton of different addresses. And it sounds like you definitely have on-chain privacy. You're sort of extending that to off-chain privacy by having multiple addresses that can be used outside the blockchain for that purpose.
Yeah, exactly. So the major issue with doing this, and because we played around with a bunch of ideas, the major issue with doing this is with Monero, you have to scan each output on the blockchain to see if it's for you. So if we did something that was like HD wallets, then it would just impact on that scanning, because now instead of scanning against one set of keys, you'd be scanning against 100 or 300 or however many sets of keys. So sub-addresses is like, how do we reduce the scanning impact while still adding this HD wallet-like functionality?
I imagine you'd want some sort of Bloom filter-like thing in order to, I don't know, maybe get a bunch of transactions and then scan over a smaller set somehow. But I'm not even sure how that could work, actually.
Yeah, it's difficult, but I think we've done a fairly good job at reducing the scanning impact. And unless somebody is creating like hundreds of thousands of sub-addresses, then it's not going to have a material impact on them.
Okay. Oh, cool. All right. Wow. That sounds pretty cool too. That a lot of interesting things coming to Monero. Anything else that you want to talk about with respect to other cryptos that are out there? Anything in Bitcoin that excites you that you are thinking about bringing to Monero?
Yeah, look, I mean, in many ways, Bitcoin represents, at least from my perspective, Bitcoin represents the pinnacle of development. And yeah, people have all sorts of complaints about it. They're like, oh, things move too slowly or whatever. At the end of the day, things in Bitcoin move a lot slower than Monero, or at least appear to move a lot slower than Monero, because Bitcoin's a much larger system. They're responsible for a lot more money. And so the developers have to exercise even greater care than the Monero developers. And so that's the fact that they can innovate as much as they can within those constraints is something that impresses me. And you know, people can have their gripes about big blocks and small blocks and fire blockstream core and all that jazz. At the end of the day, if you look at the amount of money being lost by other poorly designed blockchain projects and blockchain systems, you have to at least give them credit for that. That people that are losing money in Bitcoin are not losing money because of the Bitcoin core software. They're losing money because of, like, you know, I lost my private keys, or I like downloaded a scam wallet on my phone. And that's like, that's something that I think that as developers, we aspire to, you know, with our little $3 billion market cap, we aspire to at least being as cautious and as innovative as they are.
Yeah, I mean, you've always sort of said, "Hey, Monero's a scam. Stop buying it." You tell people specifically, "Don't buy our coin. It's more an experiment," and things like that. When do you think you'd be comfortable sort of telling people, "Hey, this, you know, we're at a point in engineering that this is actually pretty solid, and maybe you should consider buying this coin"? Would you ever go down that route, or are you forever going to tell people not to buy Monero?
Sure, that's a good question. No, look, I mean, you know, in fairness, with each day that passes, my level of comfort with Monero from a security perspective increases. The problem is that, like, my level of comfort increases, and then we make a change, like we introduced Bulletproofs, and my level of comfort goes back down again, because it's a major change, right? And so like I'm always sort of waxing and waning. It's like, yes, comfort level. Oh, okay, let's pull it back down a bit. So I don't think I'll ever, as long as we're making advancements, I don't think I'll ever get to a point where I'm like super comfortable saying to people, hey, put your life savings into Monero. That'll totally be safe and nothing can possibly go wrong. And I think it was best described to me by one of the Monero Research Lab researchers. We were having a discussion once, Brandon, and Brandon said to me, I was like, how safe do you think this is? I can't remember what we were talking about. It was early on in Monero's history. And I think we were talking about, it might have been stealth addresses or something. And he's like, well, you know, the thing is, like this seems safe, and this seems like a sound mechanism, but all it takes is some 15-year-old to come along and like, you know, go, oh no, you just do this and then it's broken, and there goes like everything you ever thought. So, you know, it happens. I mean, it happens in cryptography. It happens in cryptocurrencies. You can have like some 15-year-old come along and destroy everything you ever thought was true. We sort of hope that the assumptions that we have in Monero and in cryptography in general, we hope that the models that we work under, the assumptions that we make hold true, because they have held true for 20, 30, 40 years. And mathematically they've held true for longer. But ultimately, yeah, things can and do go wrong. And so I guess in a roundabout way to get back to your question, I don't think I'll ever have like an insane level of comfort encouraging people to use it. But I definitely am always getting more confident in Monero as a medium of exchange and as a privacy-enhancing system or privacy-enhancing technology. And as we continue to make improvements, I will be more and more comfortable with it from that perspective. As a store of value that is guaranteed safe, yeah, that's a different story.
Would you ever consider making a sidechain of Bitcoin that's got a lot of Monero's properties?
I mean, like what? Like I guess, but what for? You know, that's
one for one peg. Maybe that would be the main. Or I mean, having a two-way peg to a currency is always kind of nice.
Yeah, sure. I mean, like, but you know, then maybe we'll launch a Monero ERC 20 token as well. No, look, I mean, you know, it's definitely feasible as a peg, but I think one of the things I like about Monero is that it's not based on Bitcoin's code, and so it presents an interesting alternative, because it means that if there is ever something that's catastrophic, and you know, let's say like I don't know, the Bitcoin elliptic curve that it uses. Let's say the Bitcoin elliptic curve is found to be bad. And the ecosystem is massive, so upgrading and changing that is super problematic. In that event, you know, Monero at least represents an alternative and a safe haven whilst the ecosystem upgrades. I don't know if doing it as a sidechain with the same properties would necessarily have the same advantages as that.
That is true. That is true. I'm sure once sidechains become a thing, somebody's going to try that regardless. But yeah, it is very interesting how Monero is sort of pushing the frontier here, and that to me is one of the reasons why I follow Monero and why I've tried coding against it and things like that. So anyway, any final words or any thing that you want to tell our viewers about Monero or Bitcoin or pretty much anything, actually?
No, I don't think so. I mean, like, you know, I think that a lot of people, at least I hope a lot of people that watch your show are reasonably familiar with Monero. I do find it is kind of funny how people, even technical people, have gotten used to the number of scams and fully designed projects in this space. And I find that people are always quite surprised when I say things like, oh, Monero isn't based on Bitcoin's code. They're sort of like, oh, I didn't know that. And I'm like, well, you know, that's because so many projects in the space are either, oh, we're a smart contract on Ethereum, or oh, we click clone we click fork on Bitcoin's code repository. In 2012. And now it's like, you know, upgrading it is impossible. But yeah, like I think that it's nice to have these sort of discussions so people do become aware of the stuff that Monero is doing, and they start to become aware of the fact that Monero is it's a genuinely hard project to work on, because there is nothing in the ecosystem really except for stuff we built. There are no libraries. There's no like somebody else has done Monero J or whatever. If you want a Java implementation or a Java library, go write it yourself. You know, you've done Monero utils. So you know, I'm sure you found that when you were like, oh, I wonder if there's a Monero library you can go. Oh no, there isn't.
Yeah, and it's that's one of the things I discovered is exactly what you said. It's a completely different code base. It does everything differently than Bitcoin, and you know, CryptoNote is a whole other protocol that you know, it's genuinely innovative, which, like you said, a lot of other altcoins are simply not. They're just, you know, tweak a few parameters here or change this function here. Monero, like, and this whole class of CryptoNote coins, they're genuinely different. Everything is just, and this is why it's also hard for, you know, random web wallets to like support Monero. They're like, oh crap, we have to do a lot more work for this one than all these other altcoins because it's genuinely different. Yeah. So sorry, what were you gonna say?
Oh no, I just said yep, it is.
Yeah. Anyway, thank you, Fluffy, for joining us, and you know, hopefully we can talk again and talk about even more cool stuff that you have in the pipeline. And yeah, thanks everybody for joining us. And this song is done.